we have Aboushelbaya, who is a first-year PhD student who works at the Atomic and Laser Physics Department. God, some departments get all the cool names. He is working on plasma physics for inertial confinement fusion, not to be confused with inertial finite confusion, as I have been saying earlier. His previous talk was about helium, and he likes to do tango shows, so who knows what's going to happen now. He's going to be talking about what's so special about relativity, and he is going to introduce the general concepts of special relativity to you lot. So let me introduce Ramy.
Hello, everyone. Now, tonight I'm going to talk to you about a topic so special it has it in its name, special relativity. Now, I'm sure everybody here has heard about special relativity, and I'm sure that some people may have heard the story about when a journalist asked Einstein, how can time be relative? And Einstein replied that an hour with a pretty girl can feel like a second, while a second on a hot stove can feel like an hour. Now, while that might tell us more than we need to know about Einstein's love life, it does not really tell us anything about special relativity. It even undersells it. When special relativity says that time goes slower, doesn't mean that it feels slower. It means that it actually moves slower. In movie terms, it's less Love Actually and more Interstellar. Now, that might seem a bit unbelievable, but let me help you believe it. Tonight, you are going to prove special relativity. And you're going to do it without doing any math, for two reasons. First, I'm a physicist, so I hate doing math. Second, you don't really need it. You only need this. Now, can anybody tell me what this is? Wrong. Tonight, this is not a basketball. This is a photon, a piece of light. And like any other photon, it can only move at the speed of light, no matter who is measuring it, no matter where they're measuring it, and no matter how fast they are going. That is the basic principle of relativity, that this is not relative. So, if we try to make a clock out of this photon, with a very basic principle, like this. Now, when the photon does a bounce and gets back to my hand, we will call that a second. Now, since I'm not moving and you guys are not moving, the photon is making a distance that is the same for both of us. So we're measuring the same second. However, what happens if I move? Now, to me, the photon is still doing a bounce between the floor and my hand, still the same distance. But for you guys, it's doing a diagonal distance. It's as if it's doing a right angle triangle and it's moving through the hypotenuse. And what do we know about the hypotenuse? Exactly. So you guys are seeing it make a distance that is larger than the distance that I'm seeing it make. And since we have to both agree on the speed that this is going, this means that the time you're going to measure is exactly bigger. So your second is going to be bigger than mine. Your second is going to be bigger than mine. So while I might measure 1 second, you guys might measure 2. And so using this basic principle, you can actually travel into the future. And this is not just a theory. Scientists have taken atomic clocks and have separated them, made one move much quicker than the other, and they found that they differ when they combine them back again. So basically, Back to the Future was right. They're only wrong about how fast you need to go.
Thank you very much, Ramy. It's only at a FameLab audience can you ask, so what do we know about the hypotenuse, and expect an answer. So over to the judges. What questions do you have for Ramy?
So how far off do you think time travel is?
Well, basically, we're all time traveling, so it depends how far you want to go to the future.
Okay, he's pretty smart. If I'm driving my car through space at the speed of light, and I turn my headlights on,
yeah,
do I see them?
Yep.
Okay.
Well, let me restate that answer. Light travels no matter the same speed, no matter how much you're traveling fast. So you won't be able to travel at the speed of light. But if you're going at 99% of the speed of light, and you turn on your headlights, you will still see your headlights moving at the speed of light. And you will have 1 second equal to 100 years, so you'll probably not find any of us when you come back.
Do you realize you said you hate maths to a mathematician?
Let me rephrase that. Are you a theoretical or a applied mathematician?
I'm a statistician, so.
So that math I like.
Oh, there we go, there we go.
Thank you.
Thank you, Aboushelbaya.